So I'm going to go through just some text to provide a little bit of clarity. All right. And please bear with me on doing this. So as we saw, Sion is an item with correlational systematic error due to a common method such as extreme response categories leading to the use of middle response categories. So if you're high on PNI, you go down to -4 or something, you come to the middle. If you're medium on PNI, you consistently add 0 to it. If you're low on PNI, you consistently add 4 to it. So there are these consistent individual differences over and above PNI. That's moving you all to the middle. You lose variation because of the extreme response category. And, which is, and as a result, what happens is it's going to have less correlation with some other construct, with a measure of some other construct. Correlational systematic error occurs if different individuals interpret and use response categories in consistent but different ways. For example, C1 is an item with correlational systematic error due to a common method such as extreme response anchors, whereas C2 that we saw earlier is an item with correlational systematic error such as moderate response anchors. Correlational systematic error can be caused by the use of response scales of a similar format across items, including what are referred to in the literature as method factors. So to me, method factors are a subset of systematic error, often correlational systematic error. For example, say a certain set of response categories is employed, very good to very bad, and respondents interpret the categories in certain ways. Very good means more or less positive for different respondents, and they are consistent. Remember that, right? It's within measure correlation systematic error occurs between different items of a measure. It can be the result of responses to items being influenced by the use of a common method or by a different trait or specific method factors. So why are these items correlated? It's not just because they tap PNI, it's also they share the same method, right? And actually that's a good thing, right? It boosts your coefficient alpha. If you look at it just empirically. For instance, all positively worded items in the PNI scale may be influenced by individual differences and tendencies to agree. In my experience, sometimes the positive and negative wording will split up. And there are a couple of things going on there. Right? And so that could happen as well. Some items in the consumer ethnocentrism scale may be influenced by social desirability in responses, right? In terms of, buying products made in your own country, let's say, right? So there's a social desirability effect to it. Within measure correlational systematic error due to a common method factor is used to refer to aspects of the method that are common across all items, such as response categories. So it may arise from the use of the same response format, similar stems, completion of items in close proximity, and it can typically lead to inflated relationships between items of a measure. Why? Well, I filled out item 1, 2, 3, 4. All right, I'm going to give you a consistent response because I get it. And there's no reverse scoring, so I'm just going to keep going, right? Or even if there is reverse scoring, I know what I am on this. I got it from the first item. It's a nice halo. And I'm going to keep on responding. Within measure correlational systematic error can also occur as a result of items measuring different traits or method factors than intended. All right. So if they measure something else consistently, right? Some method factors may affect few items, such as the shared context. For example, if you take preference for, I enjoy work that requires the use of numbers, and you somehow get into enjoyment. Or if you say numbers are very good for society. There's a social desirability effect when you pose it like that. All right. So that's an example. If the trait being measured by an item is positively related to the focal construct, but a method or a different trait captured by the same item is negatively related to the focal construct, then it will be identified as random error. It's a sum of two systematic errors, but it evens out and you get a zero correlation. Right. So again, remember, everything is filled with error, including measuring random error, including reliability, which is a concept. And when you use coefficient alpha, it says, well, if the correlation is low, it has random error. Fine, we'll live with it because that's the best we can do empirically. But it could be a combination of different things, right? It should be noted that across measure systematic error could also lead to an additive effect that does not affect correlations. So if you boost price and value, you ask people, what's the price of this and the value of this and the quality of this or something. If everything gets additive, then, and there's no ceiling, then you may get the same variation. Completion of one measure may lead to inflated responses on a subsequent measure, right? And so you have different types of across measure. With finite endpoints, such inflation could decrease correlations. It hits up against the ceiling. And now we're talking about two different measures of different constructs. For example, completion of the coupon proneness scale may prime sales events and lead to inflated ratings on the sale proneness scale. You just don't know what happens when somebody fills out one measure as to what they do with the next measure. It could be halo, it could be hypothesis guessing, it could be, you know what, I got primed on this, so I'm going to inflate my responses. So if the consumer ethnocentrism scale follows a patriotism scale. Whereas the correlational type can inflate or deflate correlations, the additive type can either deflate or not affect correlations. Either you hit up against the ceiling or you basically don't affect correlations. All right, so we use system across measure correlational systematic error. An example, and I'm going to see if there's anything else here. Halo error is one example. You filled out one thing, so you think you give a similar response to other items. This happens a lot. For example, you know, teachers may gauge students on one dimension and therefore think they're good on all dimensions, right? Halo forms a halo. So that's what we mean by that. And then researchers have demonstrated how responses to earlier items can affect responses to later items. So increased reliability of later items. All right, so it's like a within measure halo effect. So this is what I was trying to explain here.